Students, welcome in continuation of the part from the photochemistry. The particular reactions, intramolecular reduction reactions. If we are having the starting reactant molecule is what? As a aromatic carbonyl compound. This is 2-methyl acetophenol. 2-methyl acetophenol undergoes photoirradiation. 2-methyl acetophenol undergoes photoirradiation. First, the molecule goes convert into singlet state. This molecule goes convert into singlet state, that is a S1. Starting reactant molecule having the ground state, this S0. After irradiation of the light, it convert into the singlet state. So the singlet state molecules as a part of this intersystem crossing using the thermal conditions. So this part from this is the fluorescence and phosphorescence phenomenon. So this is converted into what? This carbonyl compound goes to what? Triplet state. So this carbonyl compound goes to triplet state, then the alpha beta, or as you can say unsaturated hydrocarbon. For example, if we are having this is the alpha 1,3-butadienes, which is undergoes for photoirradiations, it get converted into singlet but not get converted into triplet state. Why? Because of the energy gap between the singlet and triplet is larger. So this is as having this is the 64.5 kilocalorie joules. But if we are having the starting reactant molecule is what? A carbonyl compound, it goes convert into what? A singlet state. Singlet state, after it goes convert into triplet state. This goes to converted into triplet state. This is not get converted into the triplet state because of the energy gap between what? A singlet and triplet, it is a very less. This is what? 5.0 joule kilocalories. So due to this carbonyl compound, which may be aliphatic or aromatic, it get converted into singlet to triplet state. As you can say, this get converted into singlet to triplet state. After this conversion of the singlet to triplet, so there is what? A pi bond is break between the carbonyl compound, this one of the CS2 hydrogen atom. So the bond is break by homolytically cleavage. So this pi bond is break by homolysis, this pi bond is converted into homolysis, and this bond between the carbon and hydrogen is also break by homolysis. And as we know that the part of the basic phenomenon, a bond is breaking and cleavage of the bond and fission of the bond by homolysis and heterolysis. By homolysis, there is formation of the electron species, radical species. So there is formation of the types of the compound is what? A radical species is there. This is the CS2 radicals. This pi bond is as it is. So what happened here? Next, these hydrogen atoms, this lone pair of electron and oxygen atoms having tendency, more electronegative atoms having tendency to take the proton from this carbon atoms, and it get converted into what? Hydrogen. This hydroxy group, carbonyl group is converted into the hydroxyl group. So there is what? A bond is formed between this carbon and carbon and this carbon and carbon. So there is formation of this is reduction takes place as what? As you can say, this is the photo reduction. This pi bond is from here, this OH atoms, and this is the CS3 atom is as it is. So there is formation of the final product is that as a reduction of reduction of carbonyl compound as a aromatic carbonyl compound, 2-methyl acetophenone is get converted into what? This alpha beta unsaturated hydroxy compound. Here a reduction takes place, carbonyl compound is converted into what? OH. But how the reduction takes place? Between molecules are the reduction takes place. As you can say, this is called as intramolecular reduction. So this is particularly, as you can say, the photo intramolecular reduction reaction. Here one of the reduction is completed, photo intramolecular reduction reactions.